All right, there's only one AI-generated image in this presentation, because that's like a thing I'm working on. All right, so we're flipping over to the back end, and the concept of right-sizing stack. It ties into a lot of themes, and I'm honestly probably wishing that I had condensed them a little bit more, because there's so much that's happened at this conference already that has me thinking about. But this is essentially a description of some experiments we're doing at the small level of STAC GeoParquet, and then hopefully it can be stuff that might be useful for people both at the small level, and then help us build some tooling that might be able to trickle up to those mega scales that we talk about a lot. And UC talks about billions of things, which is scary. All right, so I'm not going to do an overview of what STAC is. Matt did that earlier. Please talk to Mr. STAC if you need that. But Howard Butler describes STAC as the map to your data. And I think that's one of the key things that differentiates STAC from other things that we talk about, right? STAC is a metadata specification that is decoupled from the data themselves. So STAC can live in a database, it can live on blob storage, it can really live anywhere, and it doesn't need to live next to the actual geospatial assets that you're doing analysis on. And that is both a pain in the butt sometimes, but also very powerful. And so we'll talk about that. This is, again, Mr. STAC's diagram of how STAC has been developed, this virtuous feedback cycle between building software and then building the specification. STAC really tries to come batteries included. This is kind of an updated version of it that Julie and I have worked on a little bit, trying to pull out the kind of the users or the people in that story, right? So there's the open source developers, the nerds. There's data providers, the people that have data trying to get it to people, and then there's the people using it, the people consuming it, and they interact all through the specification, and then things like implementations help inform how we develop things. And so I would think this set of experiments really definitely came out of looking at implementations and looking at users and trying to say, okay, what's the next problem we need to solve here? So this is taken from the STAC website. This is a bunch of organizations that have supported STAC. And if you'll notice, there are a lot of very large organizations there, right? Like NASA is on there, and AWS is on there, and I think Maxar is on there. Yeah, right? So these are people that think on these very large scales of millions of pictures. But what NASA needs is not always the same thing a small nonprofit needs or a small startup might need. And so I kind of attacked this problem trying to put myself in the shoes of some of the companies I've worked with that might only have 10,000, 20,000 assets in their collection. They might use stuff from other places, but really the thing that their holdings are not as big as what NASA's holdings are. And this is kind of coming up to this thing that might be the tagline of this talk, I don't know, right? But we talk about cloud-native geospatial data. I want us to also start thinking about cloud-native geospatial metadata. So the metadata are also data that we can treat in the same cloud-native way that we treat the actual pictures themselves. So instead of always putting it down here in a database, let's start trying to put it in blob storage, be able to access it in the same nice way we access cloud-optimized geotiffs and things like that. And then, kind of as a bridge, still allow people to access it through APIs and the tools that they're used to accessing those metadata through. So that's what this is all about. And again, thank you, Raphael and Shane, for describing GeoParquet, so I don't have to. It's a nice format. Here's the size comparison, very similar. STAC is defined in terms of JSON, and so if you have 1,000 things, they can be large. You can compress them, they get smaller, but then when you go to Parquet compression, they get quite small. And one of the benefits of putting them in Parquet is that they are structured and self-describing. And so you can then use that storage format and do things with it, right? Doing that with 10,000 or 100,000 JSON things in blob storage is hard. Doing it against one file or maybe a set of globbed files in storage is nice thanks to tools like DuckDB. There are other tools. This isn't a DuckDB conference, but and so yeah, this is getting the count for 2.2 million STAC items in a second, 2 seconds, which is fun. All right, so I'm going to walk through a couple of experiments. Feel free to take pictures, but please don't quote me on any of those pictures. Shane and Raphael talked about all the knobs that you can turn. I turned very few knobs in these experiments. This was literally does it work sort of thing. And so the core of the experiment was essentially standing up 2 services. There's a STAC Fast API GeoParquet, which is on GitHub, and you may try and use. It will break. We will fix it. And then the battle-tested STAC Fast API PG Stack, which is used a lot of places, including the Microsoft Planetary Computer. An interesting bit about this is that I also ran some tests instead of going through an API client, which is what a lot of us are used to doing with like PyStack client or a web browser, things like that, I also went directly to the blob storage using a tool called RustStack, which I will talk about anon. And so we'll compare all of them. I did some experiments against 3 different data sets to try and test different ways that data can exist in the world, right? So there's just all of Colorado over all of Nape over Colorado, 2.2 billion, or million, excuse me, Sentinel-2 things, and then Open Aerial Map, which are global data set but sparse, which is kind of an interesting and different use case, right? They have stuff all over. There's actually 17,000 I screwed up when I was making the GeoParquet file, so this number is wrong, and I apologize. I don't know if Cristiano's here, but yeah. Anyways, and so we're not going to do big data analysis. We're just going to do some basic questions, right? And so like when you search for a page of things through an API or directly in the case of the DuckDB, how does it perform? And it turns out, again, this is a single GeoParquet file in blob storage going through an API layer with PyStack client. The GeoParquet file ends up returning faster than pgstack. That's sort of intuitive, where you're just grabbing everything. You're not going through a bunch of pgstack stuff. And this DuckDB line is kind of interesting because, again, this is direct access. So in the GeoParquet case, the Lambda is working inside the same region, doing a quick request, doing stuff, and then filtering stuff back to you. The DuckDB, that's just pulling it all down to my laptop. So it's kind of just a flat curve. But you can see if there's a whole bunch of things, DuckDB, that direct access gets really powerful. And that's kind of where this cloud native concept starts becoming really neat, because if you have a whole bunch of stuff, grab it, you kind of, different access patterns are enabled. One thing that we're like kind of excited about from a GeoParquet's perspective is because GeoParquet is column-based, you don't need to grab all the data when you're looking for stuff. And so the idea, especially if you're doing visualization, of just grabbing geometry and the idea of the thing or whatever, makes it so you're transferring much less data and the responses might be a lot faster. And so the idea of when you're making stack queries, really limiting it to the stuff that you actually need, or Chris and I were talking about this earlier, when you're building your GeoParquet, not putting too much stuff in it, can really increase performance and can be really important when we're building these systems. So that's kind of one. Things that it's not as good at. So it's not good at looking for like one thing and a whole bunch of things. So if I'm looking for an item of a given ID in 20,000 GeoParquet files, a relational database is very good at that. And so it turns out pgstack is better. And so that's kind of one of the takeaways here is I'm not presenting a solution where we're going to get rid of pgstack or Postgres or whatever, but for choosing the solution that's correct for your application. And it also explodes. And so I tried to just search for a single item in 2.2 million Sentinel-2 items, and it just timed out. And so, again, we can turn knobs and probably make it work, but from the naive case, it doesn't. And so, again, just saying like we're not trying to replace databases here, we're trying to complement them. This sometimes goes without saying, but I thought I'd throw this up here. So I ran these experiments for a week and like then looked at the costs for all the stuff because I had them all tagged up. I am not a DevOps engineer. Please never make me do this again. But like, the GeoParquet stuff was only S3 and a Lambda, and the Lambda was actually shared. And so it's like probably 7 cents compared to having an RDS up for that time in EC2. Obviously, your mileage may vary, but like this stuff is meant to be cheap and light and not use expensive things. All right, lots of open questions. Okay, when is it wrong? Like, I think that's an important part when you're trying to pitch anything new is when shouldn't you do that? So you shouldn't do it when you have a whole crap ton of things. Now, there's a bunch of caveats here, and I think we can build systems around STAC GeoParquet when you have a lot of things, but in this particular case, trying to go through a Lambda to enable like PyStack client to search, lots of things it broke down. Low latency needle in a haystack. So if you do a lot of, I need this a single item out of a bunch of stuff, a relational database is going to be really good, especially if that's an indexed column in the database. Or, and we talked about this earlier, if you're in a system that already has existing APIs and databases, maybe it's just easier to stand up another like endpoint on your existing API. You might not need to transfer all your millions of items over, right? So again, considering the trade-offs. This is kind of like how much time should we spend on scaling this stuff. I'm gonna honestly, I wish I had removed this slide because this conference is making me reconsider how often we should scale it, so I'm just gonna skip it. Because I think we can scale these things up pretty well. One of the questions that I get a lot is like, how do you deal with appends? So Stack is a really flexible schema. Parquet files are not. And so like, where you build a big Parquet file and then you get a new stack item and it might not match the schema exactly and things explode. My argument here is, again, for this really little use case where you only have 20,000 items or so, it doesn't matter. Just rewrite the file. And if your schema changes, it doesn't matter. And because it's like takes, what's this? This is less than a second to do, write 13,000 items. So if you have a bunch of items coming in, but or you only have a couple items coming in and you only have 15,000 things, just pull it down, rewrite it, push it back up, you're good to go. And then this is kind of a stack-ish question, but like, what's the relationship between STAC GeoParquet, which hasn't been released yet, and the actual stack specification, which is based upon all these open specs? How do we not back ourselves into a corner of having to like define what a number means, which is sometimes what happens when you make specs? And so this is kind of an open question we're thinking about. Briefly on software, so this is kind of the rough stack of what's going on here. You'll notice a really cool thing that we have a similarity here. GeoArrow was mentioned in the previous talk. That is the same code. And so that is one of the neat bits about Rust, is that that code drives the WASM for the front end. That code also, oopsies, goes up into Python bindings through Rust stack for the stuff we're doing here. And so we are sharing the same brain trust, we are sharing Kyle, you know what I mean? We don't have to duplicate this work for a bunch of different languages by making it down here and then providing bindings up. I will also note here that Pydantic also has a core written in Rust, so this is a pattern that's existing across our ecosystem. This is not just us doing weird stuff in geospatial land. Yeah, that's all I'll call it there. I'll just quickly plug Rust stack. It's pronounced Rust stack. We think, I don't know, we just made it up. It used to be called StackRS. We changed the name because this was confusing. You can read more about it if you want to. But this is both Python bindings and then a Rust library for working with Stack in Rust. It is not meant to replace PyStack, which is kind of the like de facto Python library. It's meant to augment it by interfacing with GeoParquet and things like that. So, and then I just want to shout out these folks for making this nice logo. And there are stickers downstairs. Or actually, I have no idea where it is. Upstairs, downstairs, like, this is a maze. All right, just kind of forward-looking stuff. We'd really like to cut an actual release of STAC GeoParquet. It's been mentioned several times already, and I think we need to start treating it a little bit more formally. So we also need to consolidate the tooling. There's a Python repository that does a bunch of this. There's also Rust stack. We need to figure out what the right answer is in terms of moving forward so we don't fork ourselves. And then I'd like to actually test this out for a real-world problem. So if you have, 20,000 things, and I think Ben, I don't know if he's in here, but was talking about how Overture's STAC GeoParquet isn't actually that many things. They have a bunch of vector stuff, but their actual GeoParquet files are only in the like 10 to 20,000 space. So that could be a cool application. And then if you ever use Rust stack, please let me know because I need more bug reports. That is it. Questions? Cool. yeah.
When we're thinking about what to implement, like you have that diagram, you're doing comparisons between Postgres and GeoParquet. Probably backwards, but anyway. That feels like a lot of overhead to go through like for somebody in the seat to go through and try and say, do I want to put time into figuring out the Postgres version of Stack?
Mm-hmm. Mm-hmm.
Is there best practice advice there, or is there some form of unification there that would make sense for people who are going in and trying to figure out how they want to adopt Stack with their data?
I would say there is not. I mean, there's stuff out there. That's probably a blog post I should write in 6 weeks because we need a similar experimentation. Because like this was actually prompted by an internal question at DevSeed of, hey, well, what should I use? Like that question exists for folks that are making these tools as well. So I think we can communicate more about that. Yeah.
So thanks for whipping this up. I started using it pretty early, and I've got a really nice use case. And I'm going to write a blog post with Fused, and maybe we should work together a bit on that. My use case was I had thousands of stack items and didn't want to run a server. I was lazy, cheap. And so having a STAC GeoParquet file worked really well. And then with the Fused UDF, I was getting WMS tiles out, and it cost nothing. It's like little bit of complexity. So it's really cool. I think I'm struggling to find a question. So like, awesome work. I think it's really weird putting an API, like StackFast API in front of GeoParquet, because it just like doesn't make any sense, but like obviously it's a bit faster.
Yeah, I agree it is weird, and I think it's something we probably want to end up moving away from. The thing is, there isn't other stuff that can do Stack API queries against Stack GeoParquet files, right? DuckDB, you can do a query, but that Stack API query data structure, which is that nice date-time geometry CQL2, yeah, so we've done a lot of work to turn CQL2 queries into DuckDB SQL queries. And so that magic is baked into this layer here. And so being able to use CQL2, which is popping up all over kind of the geospatial API ecosystem, to make DuckDB queries is I think, one of the more powerful parts of this. So yeah, I agree that this is weird, but I would hopefully think it's like a stepping stone into an ecosystem that can go directly to the GeoParquet and not through.
SQL now, you're saying.
I'm sorry?
We're just going back to SQL again.
It's always SQL. It's always Bobby tables. Yeah. Okay. Thanks so much.